In this video, we'll be going through Gaussian elimination and Gauss-Jordan elimination. So let's start with the most basic stuff. So a linear system can either have inconsistent solutions or consistent solution. And inconsistent solution meaning that there are no solutions for the system. So one example of this would be, let's say 0x equals 2. So there is no value for x which would satisfy this equation. So that would be inconsistent solution. And inconsistent, we have two brackets, two ways. So one is that the linear system only has exactly one solution, or it has infinitely many solutions. So one example of exactly one solution would be, one second, x equals 1. So the only answer for x here is 1, which is the solution. And for infinitely many solution, let's say x minus x equals 0. So you can put any value for x and it will satisfy this equation. So let's move on then. So here we have a linear system which has three x's and we have three equations. So the first step is to write the augmented matrix, which is simply just the coefficients of x's equal to the number. So let's do that. So we wrote the coefficients according to that. So here we have the first line 1, -2, 3, and then 5, drawing a line between them. And then here we don't have a x1, so that's why I wrote 0 here. And then it's just 2, -3, 1. Last line, last equation is 5, -8, 14, 24. So this is very simple and straightforward. And for Gaussian elimination, it is finding the Rref. So let's do that now. So here we do Rref, which is the first step is to get rid of this 5 in the third equation. So we did -5r1 plus r3. We got rid of this 5 here. And next is this pivot, and we're trying to get rid of the one below it, which is 2. So we did -r2 plus r3. If you want a more detailed explanation on Rref, you can check out my other video. So we got the final equation of this on the right hand. And now we can write in the third equation. So here we write the equations back into normal. So here if we have 0, 0, 2, so that basically means we have 2x3 is equal to the right hand side, which is -2. And we solve for x3, which is -1. And then we go to the second equation, which is 0. So there is no x1, x2. So 2x2 minus 3x3 is equal to 1. And then we know from the last equation that x3 is -1, so we substitute in there and we solve for x2. And for the first equation it's the same thing. So now if we did Rref from this step, we would have been left with only one element in each row. And then that basically means in Rref, with Rref, you will exactly just get the solution directly. So you don't have this step, which is doing this. So it's very similar actually. So this is the way to write in the matrix method. So x1, x2, x3 is equal to 6, -1, -1. And this is exactly one solution. So now let's do one example where we have no solution. So these are the equations. You can try solving it yourself. So get the augmented matrix and then do Rref. So let's do that now. So this is the augmented matrix. So you have to be very careful. If you don't have, like in the first equation, there's no x1 and you write 1 instead of 0 here. So you will get the entire thing wrong. So be very careful. And also there's the x4 missing here. So that's why we wrote 0 in the fourth column, first row. So now you have to get the Rref. So just start doing that. So here, if you started doing, if you did Rref, so first step is to switch these first two rows, which is R1 switching with R2 to bring this up, this 1 up here. And then we do get rid of this 1 in the third row to make it Rref. And the next step would be to get rid of this one. So after you did that, you will notice that you have a row which is all zeros. So no, there's no numbers over here. And you have a -8 over the right side. So whenever you see this This means that this is an inconsistent system and there's no solution. So what this line here means, 1 second, let me just get my pen. Yeah, 0x1 plus 0x2 plus 0x3, you know what I mean, and then till x5 is equal to -8. So this is not possible. So because of this, there is no solution. You can also write 0 is equal to -8, which is not possible. So one standard to follow, I'll just show you right now. So when you see this, that on the left hand side, it's a 0 row, and on the right side there is a k meaning any value except 0. So this means that there is no solution. So whenever you see this, instantly you can write there is no solution. So next up we will do an example with infinitely many solution. So this is the question. You can start by doing the REF, getting the augmented matrix and doing REF. So this is the augmented matrix. Now get the REF of this. So if we do REF, you can notice that we only have two pivots over here. So this is the first pivot, this is the second pivot. So whenever we have if we have three rows and we have pivots less than that, this means that it has infinitely many solutions. So what we call this is when we have a variable with no pivot, that row is free. So we have a free variable here. So now we write the equation. In the second equation we have y minus 3z is equal to 1, and then we solve for y, which is y equals 1 plus 3z. And the first equation we have x minus 3z is equal to minus 5, and then we bring z to the other side. So we get x equals minus 5 plus 7z. So the final answer, to keep it in this matrix format, is xyz, and then it is x is equal to minus 5 plus 7z, y is equal to 1 plus 3z, and z is equal to z itself, where z is any real number. So you can put any value for z. So that's why we have infinitely many solution, and this is the way to do it. So when we have a free variable, you have to write this, and your answer has to be in terms of z. So let's do one more example with infinitely many solutions. This is a bit tricky. So first step is to look at the matrix and identify the free variables. So to do that, you have to see the pivots. So the first pivot is this, second pivot is this. So this means that we have two free variables since there are four rows and we only have two pivots. So automatically we know that we have two free variables, and x3 and x4 are free. One more trick question which could come is that, let's say this is 2 here. Let's remove this. 1 second. So here the pivots are this first row and this one. So you have to know how to find the pivots. So that's very simple actually. So that's it. So after writing the equations in terms of x1 and x2, you get this. So this is just simple rearranging, and now we can write the final answer, which will be x1, x2, x3 and x4 is equal to, so x1 is equal to this, so just write that 3x3 minus 3x2. Okay, then x2 is 2 minus 3x3 over 2, and x3 is just x3, x4 is x4, where x3 and x4 are any real number. So don't forget to write this also. So here is just a quick example. So we have a 2 by 3 matrix where we have a k squared in the lower, and this is already an REF. So the question is asking, find the value of k where the system is inconsistent. So the basic rule is that if entire row is 0 and we have a number on the right side, then the system is inconsistent. So when k, so the answer for this is just simply when k is equal to 0. And the question also could be in that Okay, one second. The question could be asking if when the find the values of k when the system is consistent. So let's just remove this. So the answer for this would be when k is not equal to 0. Oops. So that's all for this example. So this is the last example we'll be doing. So we have a linear system which is x minus ky is equal to 1 and k x minus y is equal to 1, and we're supposed to find values of k where there is exactly one solution, infinitely many solution, and no solution. So let's start with this. So the first step is to write the augmented matrix, which is this, and now we need to find the REF. So we need to get rid of k. So how will we do that? So the step to do this is to multiply minus k r1 plus r2. So this way we will get rid of this k, since minus k times 1 is minus k, and we'll minus this from r2. So this is the REF, and now we can start by finding the values of k. So we have to see on the last row we have k squared minus 1, 1 minus k, and let's get started then. So let's try making this over here 0. What I mean is this. So let's put negative 1 actually, first of all, because we want to see because we'll get 0 0 here, and then it will be 1 plus 1. So if we put negative 1 here, we will get, let me just select pen, 0, negative 1 squared minus 1 is 0, and then we have 2 here. So this is no solution. Yeah, so this is no solution, as I was saying, and so the value of k when it's no solution is negative 1. So the answer for C will be negative 1. And now let's put 1 in k and see what we get. So we will get 0 0 and then this and then 0. So we will have a free variable here. Since there is a free variable, so this is infinitely many solution, and the answer for this is when k, let me write it betterly. Yeah, so this is for infinitely many solution, x is equal to 1, and for exactly one solution the answer would be when x is not equal to 1 or negative 1. Since this, if it's negative 1 then there's no solution, if it's infinitely many solution then it's 1, so all the other values is exactly one solution. So this is the way to do this type of question. So for exactly one solution it is x is not equal to plus minus 1. So the last type of questions which might come is a homogeneous linear system. So homogeneous linear system meaning that your right hand sides are all zeros. So a system equal to 0, and then this one also, and this. So the steps are the same. So just find the RREF or REF of this. So after finding the RREF, we get that this is 1 1 1 and then 0 0 0. So the answer for this will be the X matrix is equal to 0, since all of them are zeros. So the only solution for this answer for this linear system is that all x's are 0. And the other solutions you can get with homogeneous is infinitely many solution, which is the same as when we did with the normal linear system.